Mars tsunamis. Scientists connect impact crater with 305 meters tall wave. Scientists studying the Lomonosov impact crater on Mars believe that a massive tsunami, or possibly two, rolled across the Martian Ocean 3 billion years ago and swept across a region of the red planet known as Arabia Terra. Furthermore, they estimate that at least one wave measuring 300 meters tall deposited a great amount of sediment in that region, and it was all caused by an asteroid impact, or perhaps more. Cosmos magazine reported this week that a team led by François Costard, a planetary geomorphologist from the Université Paris-Sud in France, believes the possible sources for one or more Mars tsunamis has been located. According to their research, the scientists contend that the most probable source of the tsunami, if there was but one, exists as a 60-kilometer impact crater that is located about 1,000 kilometers off the boundary believed to be the shore of the region. However, if the sediment deposits are the result of two tsunamis, the team has found smaller craters closer to the shoreline where just a couple of asteroid impacts could have produced tsunamis capable of bearing such sedimentary loads. It was a really large-scale, high-speed tsunami, Dr. Costard explained, according to the Christian Science Monitor. At the very beginning, a crater of 70 kilometers in diameter was created by the impact. This expelled a huge volume of water, with wave propagation at 60 meters per second. The initial wave was about 300 meters in height. After just a few hours, that tsunami wave reached the paleo shoreline located at a few hundred kilometers from the impact crater. These tsunamis would be far higher and more voluminous than any produced on Earth, an effect of Mars' gravity being one-third that of Earth's. We found typical tsunami deposits along the dichotomy between the northern hemisphere and southern hemisphere of Mars, Dr. Costard, who also is member of CNRS, the National Centre for Scientific Research, in France, told BBC News. It supports that there was, at that time, a northern ocean. The new research also explains the rather strange topographical features known as thumbprint terrain, which have been found on the seaward extremes of some of the tsunami deposits. Thumbprint terrain is composed of curving, concentric ridges 10 to 20 meters high and resemble the ridges in a human fingerprint. Stephen Clifford, a planetary scientist from the Lunar and Planetary Institute in Houston, provided the explanation for the thumbprint terrain formation. He noted that the tsunami wave propagation comes from well-verified terrestrial models, and that the terrain was a result of tsunamis coming in two pulses. The first would be a result of the initial asteroid hit, which would push enormous amounts of water out of its impact path. The second pulse would be created when water returned to the displaced water area and the depression left by the asteroid from all sides. And that onrushing water would then have crashed in the center of the impact depression, creating a giant splash, and rebounded back outward as a second tsunami, one even larger than the first. More evidence can be found in what is known as a lobate deposit, which is another landform. These lobate deposits propagate uphill from the northern plains and do so in close association with a potential paleo shoreline, Clifford told BBC News. The predictions of the numerical modeling that François and his colleagues have done provide a very persuasive case for an ocean at this time. As is noted by Cosmos magazine, the idea of Mars ocean comes from Timothy Parker, now at NASA's Jet Propulsion Laboratory in Pasadena, California, who in the 1990s used Viking images and found what he believed to be an ancient shoreline. There appeared to be a coast along the edges of the terrain dichotomy separating Mars' northern lowlands from its southern highlands. It was from Parker's earlier work that scientists theorized that if one of the numerous asteroids that had impacted the Martian surface had actually slammed into that ocean, a resulting tsunami was a possibility. NASA announced in 2015 that Mars once was home to an ocean that held an estimated 20 million cubic kilometers, 12.4 million cubic miles, of water, which is more than is found in the Arctic Ocean.